Hello, friends. Welcome to Nabila Mahmi Online Maths. Today, we are going to look at the topic indices. And this lesson is going to base on the basic rules of indices. And before we move on to look at the basic rules of indices, let's look at the meaning of an index notation. An index notation is the simplest way of writing numbers. For example, if I have 2 times 2 times 2 times 2 times 2, this tells me the number of times that I have to multiply 2 together. And for me to write this one in an index form notation, what I'll do is that I will pick one of the 2's here and write it down. And then count the number of 2 that I have there. 1, 2, 3, 4, 5. And write this number as a superscript in the right hand side of the number. So I'll write my 5 as a superscript this way. And now, 2 exponent 5 or 2 to the power 5 is so called index notation. And this 2 is called the base or base number. And this 5 is called power or exponent, or you can call it index. It's just like if I have 2 times 2 times 2 times 200 times, it means I have to write it 2 exponent 100, where 100 is the power or exponent and 2 is the base. So this is how we write numbers in an index notation form. Now, let's look at the basic rules of indices. And here we are going to talk about 10 of them. You need to know these 10 basic rules before you can move ahead to solve indices questions. So let's look at the rules one after the other. So let's look at rule 1. Rule 1. If I have a exponent m times a exponent n, so you see that this particular rule, we are multiplying these things together. The bases are the same, but the exponents are different. So if the bases are the same and you are multiplying them together, what you do is that you quickly pick one of the bases and write it down. Then the next thing is you have to add the powers together. So here I have m plus n. So this is the first rule of indices, and we'll call this one the product rule. We are calling it product rule because we are multiplying them together. So let me use numbers to explain this. If I have 2 to the power 3 times 2 to the power 4, if not 2 is my base, I quickly write 1, 2 down and then add the powers. We have 3 plus 4, and this will give me 2 to the power 7 because 3 plus 4 is 7. Let's go to the second rule of indices. That is rule 2. I have a to the power m over a to the power n. You see that this time around we are dividing. And this rule states that anytime you are dividing, you subtract the denominator power from the numerator power. So I'll write my base down and then say m minus n because the numerator power is m and the denominator power is n. So it will give me a to the power m minus n. And this rule is called the quotient rule. We call it quotient rule because we are dividing. So let me use numbers. If I have 3 to the power 5 over 3 to the power 2, then this will give me 3 to the power 5 minus 2. And that will give me 3 to the power 3 because 5 minus 2 is 3. Let's move to rule 3. Rule 3, if I have a to the power m, all in brackets, then we have n outside. This time around, we have only one base, but the powers are 2 and they are multiplying together. So you quickly take your base and then multiply the powers together. And that will give me a to the power m times n. Let me use numbers here. If I have 2 to the power 3, all in brackets, 4. So this means that I have 2 to the power 3 times 4. And 2 to the power 3 times 4 will give me 2 to the power 12 because 3 times 4 is 12. Now, let's move to the fourth rule of indices. Fourth rule. This time around, we are going to have different bases, but the power will be the same. You have a common power. That is, if I have a times b with the common power being n, what you do is that distribute the power to each of these numbers, that is those in the bracket. Then I will now have a to the power n times b to the power n. For example, if I have 3 times 4 all to the power 5, what it means is that I'll have it to be 3 to the power 5 times 4 to the power 5. And this is explaining the fourth rule of indices. Let's move to the fifth rule of indices. Fifth rule. If I have a over b, all of them having the same power n, what it means is that you distribute the power to a and b. And this will give me a to the power n over b to the power n. And this one holds when b is not equal to 0. It means b must not be equal to 0. If b is 0, this rule fails to function. So let me use numbers. If I have 2 here over 3 all to the power 4, it means I'll have 2 to the power 4 all over 3 to the power 4. When you are using numbers to explain rule 5, this is how it will look like. Now, let's move to rule 6. If I have a over b all to the power negative n. You see, this here, the power was positive. This time around, the power is negative. And for you to get your result, since this one is negative, let the denominator go up and let the numerator comes down. So here I have b over a, then we change the power to be positive. When you somersault them, then you have to change the power to be positive so that you can handle the values. So to continue like this, I will now have b to the power n over a to the power n. And this particular rule holds when a is not equal to 0 and b2 is not equal to what? 0. This is the condition for this particular rule. Now let me use numbers. If I have 3 over 4 all to the power minus 2, then it means that I'll have 4 going up, 3 coming down, and this power will now tend to be positive. And now, to continue, I have 4 raised to the power 2 over 3 raised to the power 2. This is an example illustrating rule 6. Let's go to rule 7. Rule 7. This time round, we'll look at it this way. Any non-zero number raised to the power 0 is equal to 1. It means that if the power is 0, then the answer must be equal to 1. This means that if I have a to the power 0, my answer will be equal to 1. Some of these things, I will prove them later. Maybe one as the lesson goes, I will prove the reason why any number raised to the power 0 is equal to 1. I'll prove that one when we move ahead. So if I'm to use an example here, let's say 5 to the power 0, then my answer will be equal to 1. Let's look at rule 8. Rule 8. I will look at it this way. Any number raised to the power 1 is equal to that number. So a raised to the power 1 is equal to a. In simple terms, if I have 6 raised to the power 1, then my answer will be equal to 6. And this is how we explain rule 8. Now, let's move to rule 9. Rule 9. If I have a raised to the power minus n, then this time you see that the index here is negative. It means you take the reciprocal of this particular one, but the power will change to positive. What I'm trying to say is that a to the power negative n will be equal to 1 over a raised to the power positive n. So if I'm to use numbers, let's say if I have 3 raised to the power negative 4, then my answer will be 1 over 3 raised to the power positive 4. At times 2, you see it this way. Let's say if I have 1 over a raised to the power negative n, then this will be equal to a raised to the power positive n. That is how we interpret it the other way around. For example, if I have 1 over 2 raised to the power negative 3, then my answer will be equal to 2 raised to the power positive 3. And this one too holds when a is not equal to 0. Now, let's move to rule 10. Rule 10, if I have a raised to the power 1 over n, then my result will be the nth root of the base here, that is a. It will be the nth root of a. For example, if I have 1, 2, 5, raised to the power 1 over 3. Then this will give me the keep root. Keep root because the number, the denominator is 3. Keep root of 1, 2, 5. But if I have it in this form, let's say a raised to the power m over n, then I have to take the nth root of a. After that, I will bracket it, the numerator here, I'll write it as a power here. So this will now be m. So in short, let me use numbers and you see. If I have 8 to the power 2 over 3, then this will give me the keep root of 8, bracket close, all to the power positive 2. This is how we explain the 10th rule of indices 2. So before you can work indices questions without any problem, you need to know this basic rules. So that when you see any question, you know the rule that you are going to apply and continue. Some of the questions you need to even apply two or more of the rules before you can finish solving the questions. So next time we meet, we'll be looking at how to solve indices questions. That is my next video on this particular topic. So what you need to do now is, if you have not subscribed to my YouTube channel, please just go to YouTube, search for Nabila Mahami Online Maths. Subscribe to the YouTube channel, press the notification bell so that anytime I upload a new video, you will be notified and go and watch. You can also share my Facebook post for your friends to watch. Thank you and have a nice day. Bye bye.